we have the ESTHub Vision Day 2022, and the current part of this event is devoted to the topics related to the land. And the first presenter is Lea Hallik from Tartu Observatory, one of the most well-known remote sensing facilities in Estonia, and she will talk us about using remote sensing with this task to assess the situation in bogs. Lea, the floor is yours.
Thank you. I hope you all can see my screen already.
Yes, your first slide is nicely visible.
Yes, I will talk this time about Satiladu service, which is not so usual for scientific calculations, but rather for the widespread use to assess particularly Sentinel-2 images to get the fast preview. It is possible to select either visible RGB images or different vegetation indexes to display. It is possible to select start and end dates to get the preview of certain time period. In particular advantage of this service is that besides the satellite Sentinel-2 images, it also provides access to a range of spatial data what Estonian Land Board is collecting and serving. So the additional data what can be accessed now through the Satiladu to display for interpreting Sentinel satellite images includes soil map data. There are a range of different landscape type masks. It is possible to select a forest mask or mask of fields or wetlands, which is something I will use this time in the examples. Estonian Land Board is also making orthophotos from the airplane, and the same flight can also provide data from LiDAR. So the current very new development in Satiladu is the idea to calculate from orthophotos also the vegetation index NDVI, which is normalized difference vegetation index, the most common vegetation index, which gives mainly information about the amount of green vegetation. Since the flights for orthophotos are made 1/4 of Estonia per year in summertime flights. So the same area can provide the repetition time in the same area would be once per 4 years. which is quite unfrequent compared to how much we have cloud-free days to get satellite images. Currently, the southeast quarter of Estonia, which was measured with here with all the photos in this summer 2021. And the flight was in the first half of June, covering all this area. Currently, Satiladu provides NDVI data for this period in this quarter of Estonia, and hopefully for upcoming years, the whole Estonia would be covered. The idea to calculate NDVI from those orthophotos has been actually around quite a long time, since the equipment that Landport is using, the Leica camera, it also contains near-infrared channel, allowing vegetation indexes to be calculated from this data. Now, the color scheme in Satiladu is the same that is used for Sentinel-2 images NDVI. The darker red corresponds to values below 0.1. Then from light red to yellow is up to 0.1, 0.5, and green values correspond to higher NDVI values between 0.5 to 0.9. Now, the same region from the similar time in Sentinel-2 looks a little bit different in NDVI values, as can be seen from the color difference, even if the time of the flight is similar. Here you can also see the formula for normalized difference vegetation index. It's using near-infrared and red channels. The formula for calculating the same index from orthophotos is currently a little bit changed, because the sensitivity of different channels in the camera used for flights is a little bit different compared to Sentinel-2, and the idea has been to adjust the value more similar, adjust the NDVI value calculated from orthophotos to be more similar to the values which are coming from Sentinel-2. The example area, what I would use now, is near Järvselja, Ullika Bog, and the forest next to it, to cover range of tree heights. This is now the view what you can see from Satiladu service. It is possible to click if you would open the link that I sent in chat, then you would find yourself in the same area with couple of satellite images already there, which we will see also in the presentation. And it is possible to change the satellite images and to select which index is shown from satellite data, and on the side it is possible to select whether to display orthophoto or some masks or other features as auxiliary data for the same region what was explored through satellite image. Now here is the RGB of satellite data from the same time, and one most commonly used feature from orthophotos is to compare the same region with higher spatial data from orthophoto. Now we have added the NDVI, which is calculated from orthophoto to improve the interpretation of NDVI from satellite data where the pixel size is 10 meters. The time is again relatively similar, and features which can be seen in orthophoto are, of course, there is much more information, but not all of that will be actually interesting and needed in many cases. But it would definitely help to understand where the satellite pixel information is coming from. Here is the example of some previous box study. The tree height is definitely something what is most commonly most widely influencing NDVI values, but it is also depending on the time of the year how strong is the correlation between NDVI and for example tree height. It is higher in spring time, but lower in springtime, while higher in summer. And it is strongly depending on whether the bog is covered with bigger trees, or it's in the bog case if it is open bog without trees. From the LiDAR data, we can see also the vegetation height, which for our case is varying from absence, which is white, to quite high tree cover. One mask which is particularly useful is the mask of tree height less than 1 meter, which is currently in this example above orthophoto, and it is good to pay attention to the tree shadows, what you can see. In the case of NDVI, for example, the same tree shadows clearly appear to contribute into the signal what is generally seen, and which is also relevant for any interpretation of NDVI calculated from such high spatial resolution data like coming from airplane, even more relevant for any kind of drone application, for example. The same mask can be displayed above satellite image, which is the main purpose of ESTHub and also the Satiladu service itself to interpret satellite data. There is also masks for wetland, which is showing different information compared to applying over same area. For example, this mask of tree height less than 1 meter. So the main challenge is this temporal versus spatial resolution, because orthophotos do have very good spatial resolution, but it is never possible to have frequent measurements in such high resolution. So in the case of satellites, if we would see the same region, for example, in June and July, there is in RGB not that much difference, although some bigger difference if to compare the same area in autumn. We have a lot of clouds, but it is still quite many satellite images available for each location per year. If we see the NDVI values, for example, in spring and later beginning of summer, when in this particular case also the orthophoto would originate in the mid-summer or in the autumn. Even in such vegetation, which should be very stable, bog should be something where differences are really small. Forest itself as well is as stable vegetation type as possible. Even here, we need to consider changes which happen during the year. Even more complicated would be with agricultural fields, where just different years would mean different crops, and therefore the information what can come from orthophotos would be just for 1 year, maybe 4 years ago. But still, there seems to be potential in trying to calculate vegetation indexes from orthophotos. Since Estonian Land Board is dealing with both, providing Sentinel-2 images, satellite data, and conducting flights for orthophotos, then it would make very good sense if Land Board would also conduct some more serious ground validation for Sentinel-2 based on some orthophotos made by another branch of the same larger structure of Estonian Land Board. There is also soil map, which is very useful layer what can be placed for inspection now above the satellite image. And I think that everybody would be very much encouraged to make suggestions to ESTHub. What kind of spatial layers what Land Board is already actually serving, which layers should be made available also through the Satiladu to directly compare with satellite images. So thank you.